Hello and welcome to lesson 3 of module 5. Today we are going to create rules or formulas for given functions. You'll know you're successful when you can create an equation or a rule for a given function by identifying relationships within a table or a word problem. As always, keep in mind our class expectations. Keep your video on, please, and your mic muted. Show your thinking in your work. Participate. Have appropriate conversations. Communicate any tech issues with me, and always make sure you're being respectful, responsible, and safe. All right. In the last lesson, we looked at several tables of values showing inputs and outputs. This is your input, it's your x value, and your output is your y value. So I want you to imagine this machine right here. You put your x value in, right, and then the y value comes out. For it to be a function, each x value that you put in can only have one number that comes out. So let's just check really quick and see if this table here is a function. All right, so if I put a 1 in, the only thing that comes out is a 1.25. There's no other 1s here, so nothing else is coming out. If I put a 2 in, only a 2.50 comes out. There's no other 2s as x's, nothing else is going to come out. 3, 375, yep, no other 3s. No other 4s, no other 5s, no other 6s, no other 7s or 8s. So this is a function. And the reason being, each input, which is our x, has only one output. Okay. We learned in the last lesson it's okay for there to be this two of the same outputs as long as they had different inputs that created them. So what that actually means is same y's. That's okay, as long as they belong to different x's. All right, so this is what we learned in the last lesson. We're just going to continue talking about this background knowledge on the next slide. So here on this slide, you'll see that it is the exact same table, and we have a graph off to the side. So basically, they have taken each of these values and they've created a coordinate pair. So there's my x and my y. So they graphed this as 1 for their x, 1.25 for their y. So they went over 1, up 1.25, and then they put a little point. Okay, and then their second point was 2.50. So they went over 2, up 1, 2.5, and made a point. And then their third point was 3.75, and they did the same thing, right? 1, 2, 3, up 1, 2, 3.75, and made a point. And you'll see that the relationship that they created made a line. And what this means is that the relationship is linear. Okay? So this is a linear relationship, and you can see that because it creates a line. So it's a linear function. But we don't always want to have to graph it to figure that out. So instead of having to graph this to figure it out, we can just create an equation where there's a constant. If there's a constant that applies to every single row in our table, if there's a constant relationship, if there's a slope m, then we know that's a linear equation and it would graph as a line. So what we're going to do right now is just create an equation based off this line. So remember, we write our linear equations in y equals mx plus b, where m is our slope, b is our y-intercept. So the first thing I want to do, I'm going to find my y-intercept. So looks like this intercepts this y-axis. Here's my y-axis. And this line intercepts this y-axis right here at 0. So my slope for this is 0. And then I want to find my my y-intercept for this is 0, and I want to find my slope or my constant rate. So remember, we do that by finding y divided by x. So for this one, I'm just going to use that first row, 1.25 divided by 1, which is equals 1.25. This becomes y equals 1.25x plus 0. That is the equation for this line, and it'll work for every single row in this table if we were to plug it in. Okay, say, okay, well, our x is a 2, so we put a 2 where this x is. 1.5 times 2 plus 0, that gives us our y value, which is 2.5. And you'll see that it graphs the line. So today we're just going to be creating these linear equations for tables of values to prove that they are linear. All right, and all we have to do is identify our y, our m, and our b to create our equation. Okay, make sure you have this down, and we're going to move on into our actual examples. All right, example number 1 says Walter walks at a constant speed. If there's a constant speed, that means this is a linear function or a linear equation. That's my clue here. Of 8 miles every 2 hours. So this is my relationship, 8 miles every 2 hours. I want to remind you that time is always your x. Okay, so our hours is our x right here. And then our y is just going to be whatever is left. So 8 miles, that would be our y value. Okay, it says describe a linear function for the number of miles he walks in, 6 hours? Oh, x hours. What is a reasonable range of x values for this function? So the first thing we're going to do is we're just going to create a table to represent this relationship. So I'm going to put my x and my y. It doesn't matter if you do this vertically or horizontally. I'm just going to set it up like so. Okay, and then I'm going to fill it in. So for my x, I had a 2. My y, I had an 8. Right, maybe I want to double that, so I'll double each side, so this becomes a 4. This becomes a 16. Maybe I'll triple it. 2 times 3 is 6. 8 times 3 is 24. Okay, so I've made a table of values for this relationship. The next question says, is the relationship linear? So linear means that it is constant. I already said this up top, but yes, it is constant. It's linear. It has a constant of proportionality. So we're going to find that constant right here. So remember, we find the rate by doing y divided by x. In this case, I'm just going to use this top row, my 8 and my 2. So this becomes 8 divided by 2. And 8 divided by 2 is 4. So the constant rate, or the m, is 4. All right. From there, we don't have a b. We don't have an additional value being added on. In the next couple of examples, you'll learn what that looks like and how we find that, if that's the case. But there's no other number mentioned in this example, and so we don't have another number being added to our equation. So we're just going to write our equation in y equals mx plus b form. We know that our m is a 4, so this becomes y equals 4x. And we don't have a b, so we can just put plus 0, or we don't have to put that at all. We could just put y equals 4x. Okay? I'm going to go ahead and just put y equals 4x. So it's as simple as it can be. That is my relationship. That is my equation. And it says, does it work for each row in the table? So does y equals 4x work for every single row? Well, let's try the first one. Y equals 4 times x. Well, the x in the first one was a 2. Does y equal 4 times 2 is 8? Does y equal 8 for the first one? Yeah. Okay, let's try the second one. Y equals 4 times x. Well, the x in the first one is 4. 4 times 4 is 16. Does y equal 16? Yeah. And then lastly, y equals 4 times 6. 4 times 6 is 24. Does y equal 24 in the third row? Yes. So it works for each row. This is a linear function. We've created a linear equation with our constant rate that we found. And just make sure you have this down. Let me know if you're having any questions in the chat. We've done this many times before, so this is not our new learning. We're just building up into our new learning. Okay. All right, example number 2, it says Veronica runs at a constant speed. If she runs at a constant speed, then we know this is linear. Okay, the distance she runs is a function of the time she spends running. Now what this means is the distance is a function of the time she spends running. That means our distance is our y, our time is our x, and we already know that. So we have a table that they've already created for us below. So at 8 minutes, she runs 1 mile. 16 minutes, she runs 2. 24, she runs 3. 32, she runs 4. Is this relationship linear? Well, you should know. You saw that word constant up top. So yes, it is linear. There's a constant relationship. Okay, well, what is the constant? How are we going to find that? We're going to do y divided by x. Does not matter what row you choose. I'm going to choose this one. Y is 1. X is 8. 1 divided by 8, you can leave it as 1/8 or you can turn it into a decimal. I'm going to leave it as 1/8. So my slope or my constant rate is 1/8. Okay? It says write an equation to represent the function. So we want to write this in y equals mx plus b format. There is no b here. Okay? And there's no b because there is no other number mentioned. There's no other thing going on between our two values in each table or in each row. And we'll learn about when there is a b again coming up soon in the next example. So there's no b. We just leave that as a 0. Our m, we found that that was 1/8. So that's what we're going to change that to. So our equation is y equals 1/8 x plus nothing. Okay? There's nothing being added, so I just leave that blank. All right, the next question says, how far would she run in 40 minutes? Okay, so we're going to use this equation, y equals 1/8 x. We're going to plug in this 40 minutes in, and we're going to find out what the other value is. Now, remember, minutes is x, so we're going to change our x to a 40. So this becomes y equals 1/8 times 40. Okay? And if you do this in your calculator, 1/8 times 40, this is the same as saying 40 over 8 or 40 divided by 8. And when you do 40 divided by 8, you get 5. So how many miles can she run in 40 minutes? She can run 5 miles. And again, all we did there was we took our equation, we plugged in our value, and we found our other value. In this case, we plugged in our x, and we found our y. All right, and the last one, it says, how much time would it take for her to run 10 miles? So this time, we're not plugging in our time, we're plugging in our miles. So remember, miles is our y. So this time, we're plugging in our y. So we have y equals 1/8 x. We're now changing this y to be a 10. So now my equation says 10 equals 1/8 times x. And we're solving for that x. Right now it's being multiplied by 1/8, so now we need to divide by 1/8 on both sides. Over here it cancels, and I'm left with x. And if you do 10 divided by 1/8 in your calculator, you'll get a decimal, or you could do 10 divided by 1/8 out like this, and then you change opposite, and you get 80 over 1. Which is the same as 80, okay? So no matter how you do it, if you do it in your calculator, if you do it by hand like I just did, you're going to get the answer of 80, which means how much time does it walk her to run, or does it take her to run 10 miles? It takes 80 minutes. So on this slide, we were able to use our equation to answer some questions that weren't in our table. All right, that was the new addition here. Let me know if you have any questions. Make sure you have it written down. And then we will move on to our example number 3. All right, so far in all of these examples, when we've written our equation y equals mx plus b, we have not had a b value. All right. All of these have started at 0, 0 on a graph. They've all had a y-intercept of 0. The b has been nothing. We've added nothing extra. Well, in this example, you're going to find out what it looks like when our equation does have us add in a b. Okay, so let's read this example and we'll talk about where we can find that b. It says water flows from a faucet into a bathtub at a constant rate. Okay, so we know that this is linear. Constant rate of 7 gallons of water. So this is my rate. I'm going to highlight it. 7 gallons of water pouring out every 2 minutes. So that is my constant rate. That's where I'm going to find my m value. This is my constant rate. One thing you should know, your minutes, that's time, so that's always x. Your gallons, that's y. Okay? The bathtub is initially empty, and a plug is in it. Determine the rule that describes the volume of water in the tub as a function of time. If the tub can hold 50 gallons of water, how long will it take to fill the tub? So as I read that, I didn't find any other information. So at this point, there is no b. There's no y-intercept. It's just starting at 0 because it is initially empty. We're starting with 0 gallons in this tub. On the next slide, we'll change this up a little bit and you'll see what it means to actually start with gallons in the tub. So we're going to start this off, create a table to represent the relationship. So I have x, which is my minutes, and I have y, which is my gallons. All right, and it says 7 gallons every 2 minutes. Okay, maybe I double that, create a 4, 14. Maybe I times it by 10, 20, 70. I've just created a table by multiplying, okay? Is the relationship linear? Yes. We know it's linear from our description up top. It said it had a constant rate. Okay, what is the constant rate? Well, we're going to do y divided by x. In this case, we have 7 divided by 2. You could turn that into a decimal if you want. I'm just going to leave it as, actually no, I'm going to turn it into a decimal. So 7 divided by 2 is 3.5. So our m, our constant rate, is 3.5 gallons every minute. For every 1 minute, we do 3.5 gallons. We're going to use this constant rate to create our equation to represent the function. So remember, our equation is y equals mx plus b. We don't have a b in this case, so that's just going to be a 0 or nothing's going to be added on. And we found our m is 3.5. So this equation becomes y equals 3.5x. Okay, again, still no b for this one, but it'll be in the next one. The last question says, how long will it take to fill the tub with 50 gallons? Well, gallons is our y, so we're going to put 50 for our y. So we have y equals 3.5 times x. Well, now, again, we're looking for 50 gallons, so our y is a 50. And we're trying to figure out how much time that's going to take, what the x is going to be. So when the y is a 50, what is the x going to be? We will solve. So to get x by itself, we're going to divide both sides by 3.5. Over here it cancels. I'm just left with x. And we're going to do 50 divided by 5 and 50 divided by 3.5 in our calculator. And I get a long decimal. I'm just going to round it off, 14.29. All right, but what does that mean? How long does it take to fill the bathtub? Well, it's going to take 14 and a half, or 14.29 minutes. To fill that bathtub. Okay. Make sure you have this down. Let me know if you have any questions. And on the next slide, we're going to figure out what our equation looks like when the tub is not initially empty. Okay, that's going to affect our B value in our equation. Make sure you have this down before we move on. All right, so this is where we actually figure out how to write an equation that has a B value attached to it. So y equals mx plus b. So far, we absolutely always know how to find our constant rate, but we haven't had any equation that had an initial starting value that wasn't at 0. Let's go through this one and see what that looks like. So now assume that you're filling the same 50-gallon bathtub, so it's the same bathtub, with water flowing at that same constant rate. They already gave us our M. I'm going to write that in there. But there were already initially 8 gallons of water in the tub. So initially we're starting off not at 0, we're starting at 8. So this is going to be our B because we're not starting at 0. We're going to be adding on 8 gallons to begin with. Now the question says, will it still take 14 minutes to fill the bathtub? My assumption, before I even do this math, obviously not. If there's already water in the tub, why would it take the same amount of time to fill it up as when there's no water in the tub? But let's go ahead and write this out. So it says how many gallons were already in the tub and should be added in on our equation. So there were already 8 gallons that we're going to have to add in. So we're going to put plus 8 somewhere in our equation. And where it's going to go in our B because we're not starting at 0, we're starting at 8. So we're adding 8. Okay? What's the constant rate? Well, they gave us the constant rate already in the word problem, but we figured out in the last one, the constant rate is 3.5. For every 1 minute, 3.5 gallons is filled. So now we're going to use this knowledge to create our equation. So remember, it is in y equals mx plus b. In this case, our m is still 3.5, but we're not starting at 0. We're starting at 8. We're adding 8 on to begin with. Okay? Now it says, fill in the table below. So we're going to use this equation that we just made to fill in the table below and then answer the question. So for the first one, y equals mx plus b. Y equals 3.5 x. I forgot to add the x in. Sorry about that. X plus 8. So the first x that I'm going to plug in is a 0. So y equals 3.5 times 0 plus 8. Well, 3.5 times 0 is 0. Add an 8. Y equals 8. So at 0 minutes, before we even turn the bath on, how many gallons are in the tub? 8. This is what you look out for in a table when you know what your B value is. So whenever there's a 0 for our x and there's a number for our y, that means on a graph, if you were graphing this, that it's not going to go over at all on your x, it's just going to go up. So it's going to have a y-intercept that's up a little bit more than a 0. Okay? So let's do our 3 value now. Y equals 3.5 x, this time it's a 3, plus 8. Well, 3.5 times 3 in my calculator is 10.5. And we add on an 8, and we get that y equals 18.5. So after 3 minutes, 18.5 gallons are filled. Okay? Next one, y equals 3.5 times 6 plus 8. 3.5 times 6 in my calculator is 21. 21 plus 8 is 29. 29 gallons in 6 minutes. Okay, now let's do 9. Y equals 3.5 times 9 plus 8. 3.5 times 9 in my calculator is 31.5. Plus 8 in my calculator is 39.5. And then the last one here, y equals 3.5 times 12 plus 8. 3.5 times 12 in my calculator is 42. Plus 8 is 50. So I've filled in my table with my equation, and I've actually come to the conclusion. I know how long it's going to take to fill up this tub because the tub is 50 gallons, right? And I just did that one. 50 gallons is going to take 12 minutes. Right? So will it still take 14 minutes to fill the tub? Nope. It took 12 minutes to fill the tub. All right. Make sure you have this down. Let me know if you're having any questions, and we're going to move into one last example before our practice. All right. Example number 5, it says water flows from a faucet at a constant rate. So this is linear. Assume that 6 gallons of water are already in the tub. So 6 gallons of water are already in the tub. We're going to be adding a 6 to our equation. That means that this is our B. This is our B value. Okay? This information is recorded on the first column of the table below. Does everyone see this first column showing that before we even turn the faucet on at 0 minutes, there's already 6 gallons in the tub. So if there's already 6 gallons in the tub, that has to be added to every single row that's added in our equation, okay? The other columns show how many gallons of water in the tub at different numbers of minutes, since we noticed the running of the faucet. Okay, so let's go ahead and fill this table out below. It says how many gallons were already in the tub and should be added in our equation. 6, right? So 6 should be added in our equation. This should be our B value. Okay, from there we have to find the constant rate. Well, this is where it gets a little bit more difficult, because if I was just going to find the constant rate by doing y divided by x, it's not going to factor in this 6. So to find the constant rate when there is a b, we have to do a little bit of extra work. So we have to do y minus our b divided by x. All right? So that is how we're going to find the constant rate here. We're going to take away that 6 from our y, and then we're going to divide it by our x. So in this case right here for this row, we have 9.6 minus that 6 value, and we're going to divide that by 3, which is our x, okay? So 9.6 minus 6 is 3.6. Divide it by 3, we get 1.2. So our constant rate here is 1.2. That means every minute we're getting another 1.2 gallons in this tub, okay? So the final equation here, we have our m, we have our b. It should be y equals 1.2x plus 6. And we're going to try this out and see if it works for our table, okay? 1.2x plus 6. Let's try it with this row. So if our x is a 5, let's plug that in. Y equals 1.2 times 5 plus 6. Let's see if it checks out and becomes a 12. So 1.2 times 5, if I do that in my calculator, let's see what I get. 1.2 times 5, I got 6. And we add on a 6. Well, 6 plus 6 equals 12. Did it work out? When x was a 5, was y a 12? Yep, worked out. Let's try it for the last one. Y equals 1.2 times 9 plus 6. Let's see if it checks out and becomes 16.8. So 1.2 times 9. Doing my calculator, I got 10.8 plus 6. 10.8 plus 6 is 16.8. Checks out. So this equation does work for my table. This is my linear equation. All right. So again, I found out what my b value was. I took that away from my y and then divided by my x. Okay, we'll do that in the next coming exercises as well. You'll go over this a little bit more. but I don't think this will be on your exit ticket yet. Okay, make sure you have it down before we move on. All right, for exercise 1, I want you to try this on your own before we go over it. It says, Hannah claims she mows lawns at a constant rate. The table shows the area of lawn she can mow over different periods. I want you to tell me, is the relationship linear? Find the constant, write an equation, and then check, does that equation work for every single row in the table? Okay, I'll give you 2 minutes to do this before we go over it. All right, you should have decided that yes, this constant rate tells me that this is a linear equation. We don't have anything being added on. There's no 0 and then a number, right? So this is an equation that starts at 0 on our y-axis when we graph it. There's no b. So we just need to find our m regularly. We do y divided by x. Doesn't matter which one you do, 36 divided by 5. You will come out that the m in your equation is 7.2. That's your constant rate. 7.2 feet are mowed every minute. So we write an equation, y equals 7.2x, and you see, does that work for every single row in your equation? Is 7.2 times 20, 144. Yep, checks out. Is 7.2 times 30, 216. Yep. Is 7.2 times 50, 360. Yes, so it works for every row in our table. Make sure you have this down. Let me know if you have any questions. And we're going to move to exercise number 2. All right, exercise number 2, it says a linear function has the values below. The information in the table shows the volume of water in gallons that flows from a hose as a function of time, the number of minutes the hose has been running. Please find your constant rate. There's nothing else being added on here, so just literally do y divided by x. Find your constant rate, write an equation, and then I want you to try to answer these 2 questions with your equation, okay? You don't have to do these ones yet. Okay, just do the ones that are starred first. All right, take a couple minutes to get those answered before we go over it. All right, for number 1, what is the constant rate? Y divided by x. 44 divided by 10. The constant rate is 4.4. So we write that in the equation as y equals 4.4x. Okay? It says how many gallons will be filled in 250 minutes? Well, minutes is our x, so I'm going to be changing this x to a 250. Okay? Y equals 4.4 times 250. And when I solve that, I get 902 gallons. Okay, check that with my work. The next one is asking us how many minutes would it take to fill 396 gallons. So this time we are changing our y. So this becomes 396 equals 4.4 times x. Well, we're dividing both sides by 4.4 to get our x by itself. Over here it cancels. Over here 396 divided by 4.4, I get 90. Right, check that with my work as well. Let me know if you have any questions. All right, the last one says the average swimming pool holds about 17,300 gallons. How long will it take to fill? So I'm going to change my gallons, which was y, to that number, 17,300 equals 4.4 times x. I'm just using the equation that I came up with. I divide both sides by 4.4. Over here it cancels, I'm just left with x. Over here, 17,300 divided by 4. I get x equals 4,325. So 4,325 minutes is what it will take to fill that swimming pool. Okay? Now it says, well, what if 3/4 of the pool is already filled? How long will it take to fill the remaining 1/4 of the pool? So I'm just going to have to use this and multiply it by my 17,300. So 1/4 of the pool. So 1/4 of 17,300 I'm going to plug that into my equation to find x. Okay, first thing I need to do is my multiplication. 17,300 times 1/4, or that's the same thing as saying divided by 3, is divided by 4, is 4,325. From there I can divide both sides by 4.4 to get my x by itself. And what do we get? I get this crazy big number, 982.95, very long. Just going to stop right there and round that off as minutes. Okay? All right, make sure you have all this down before we move on to exercise number 3. All right, exercise number 3, it says, recall that a linear function can be described by the rule in the form of y equals mx plus b, while m and b are constant. This table below has a function. We just want to create the function. So using the table, determine what number is being added on from the beginning. So again, you look at the row that has a 0 for your x and figure out where is that y-intercept going to be. Okay, that's the number you're adding on. After that, I want you to find your constant. So remember, if we're doing a constant where there is a b, we have to do y minus b divided by x. That will give you your constant. Okay? Then write in your equation and fill in the table with your missing values. Okay? Take a couple minutes to try this before we go over it. All right, for the first one, when we are at 0, our output is at 4. That means our y-intercept is at 4. Our b equals 4. Okay? From there, we're going to create our constant rate. We're going to find our m. So we're going to do y minus b. I'm just going to use this row right here. So y, 24, minus b, which was 4, divided by x, which is also 4. 24 take away 4 is 20. 20 divided by 4 is 5. So my constant rate is 5. So now that I have my y-intercept and my slope, or my constant rate, I'm going to write my equation out. Y equals mx plus b. This is now y equals 5x, because 5 is my m, plus 4. Okay? And we're going to use that to fill in our table with missing values. So starting here, we have a 15 for our x. So this becomes y equals 5 times 15 plus 4. If I do this math, 5 times 15, 15, 30, 45, 60, 75, plus 4 is 79. Okay, next doing 20 for my x. Y equals 5 times 20 plus 4. 5 times 20 is 100, plus 4, 104. Next, I'm going to do the 23 for my x. So y equals 23, y equals 5, times 23 plus 4. 5 times 23 in my calculator is 115, plus 4 is 119. So I filled in my table with that equation, and I'm good to go. Let me know if you have any questions here before we move on. All right, our lesson summary today is that a linear equation y equals mx plus b describes the rule for a function, and we can call any function divided by a linear equation a linear function. It means the same thing. So don't forget a couple things here. This is your slope, or your constant rate. Okay, and this is your y-intercept. This is where your graph starts. Okay, what's being added on to begin with. If there is a b, then you have to find your m. Instead of doing y divided by x, you do y minus b divided by x. Okay? And that's really only the new learning that you've had here today. Everything else was kind of review. We're going to move into our exit ticket now. All right, here is your exit ticket, guys. You're going to be doing all of this in Galileo. It says the information in the table shows the number of pages a student can read in a certain book as a function of time and minutes spent reading. Assume a constant rate of reading. I want you to answer, is the relationship linear? Find your constant rate. Write an equation. And then I want you to answer these questions. How many pages can be read in 45 minutes? Remember that minutes is your x. How long will it take to read 396 pages? Remember, pages is your y. You're just going to be using your equation. And then the last one, if the student has already read 3/8 of the 396-page book, how much will it take to read the remaining 5/8? So basically, you're just going to be multiplying 5/8 times 396. That's how many pages are left. And you're going to be using your equation to do that. All of this is going to be in Galileo. So please make sure you are completing it there. When you're finished, work on your lesson reflection. Look for any missing work that you might be doing in our Google Classroom post where it says missing work. Complete that missing work, mark it as done, and then work on your weekly work, Moby Max and Prodigy.